We already know about the types of interactions atoms will participate in to form molecules. These are the covalent bonds and ionic bonds that hold molecules together. But there are also certain kinds of electrostatic interactions that an entire molecule can make with other molecules. These are called intermolecular forces, and they won't be actual chemical bonds, but they can be fairly strong, and they determine many characteristics of a substance, so we need to learn about them. One of the things that intermolecular forces will determine is the phase that a substance will be in at a particular temperature. The stronger these attractive forces, the more the molecules stick together, and will thus be a liquid or even a solid at higher temperatures. That's because particles in a solid or liquid are close together, essentially touching, and thus participating in interactions. In a gas, the particles are far apart and not interacting, so the stronger the attraction between the particles, the more heat energy that will be needed to overcome the attractions and put the substance into the gas phase, which translates into a higher boiling point. Raising the temperature means adding more heat energy, which means generating more kinetic energy for the particles, which eventually results in vaporization at some temperature that depends on the identity of the particles. We see these processes happening all the time. Take water, for example. When water vapor in the atmosphere cools, it will condense, which we might see in the form of dew on a leaf. This is because as they cool, the molecules travel more slowly, which makes it more feasible for them to attract one another through intermolecular forces and begin to stick together. Water will boil, freeze, and melt for similar reasons. The change in temperature results in a change in kinetic energy, which makes the molecules either stick together more efficiently or less efficiently. Solids maximize intermolecular attractions because the particles are not moving, so they are locked in a lattice that will obey a geometry that allows it to be at the lowest energy possible. Liquids exhibit intermolecular forces, but the particles are constantly in motion, so these interactions are fleeting and ever-changing. And a gas will not exhibit these forces, as the particles are too far away from one another to interact. Once again, we want to stress the idea that intermolecular forces are very different from the intramolecular forces within a molecule. The covalent OH bonds in a water molecule are much stronger than the intermolecular force that occurs between two separate molecules by a huge factor, as we could see from the energies needed to boil water versus the energy needed to split water molecules into hydrogen and oxygen. There are a number of different types of intermolecular forces, so let's learn about them one at a time.